Hello everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. That's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody. Welcome to Devember Day 8, the day that we panic hardcore because we're working on C# code and we're not entirely sure how to go about doing so. I am your host, ODAT Nerd, here, and you just caught me looking a little bit at the asynchronous action in the .NET library. Now, we looked over this way back on day 1, but I want to go over this one more time to cement in my head how it's working. I spent a bunch of time today trying to think of how exactly to structure this code to do what we want. And this is one of those things where, due to my not having enough experience with using it, I'm not entirely sure what the best way to go is. Now, that's not to say that I think what I did in the Python code is the quote unquote best way to go, but it's a way that I knew would work for what I was trying to do. Here, we're doing something completely different. And um, I, it being Saturday today and Sunday tomorrow, those are traditionally the 2 days where I have the least free time to do anything. Weekend days are the days we do our longer exercise walks. We spend a lot of time together as a family. We do our weekend shopping and chores to get things ready for the week. So I don't really have a lot of time to just sit and wrench on code outside of in this case, this hour here. Now, if I was doing a traditional Devember, not live streaming it and just blogging it at the end, or just doing regular coding and then creating a vlog at the end, then I would probably have way more time. Certainly, if I was writing a blog, it takes a lot less time to get the vlog up and out than it does to try to type something, but I really don't want to have to try to type something. That's just my way of saying that expect for the Saturday and Sunday episodes of this, if we don't have a set task in mind ahead of time, things might be a titch slow. The good news is that the UPS man accidentally delivered a package to us today, of all days, after deciding for yesterday that they didn't know when it might come due to weather conditions, and there were no weather conditions. But in any case, getting back to the task at hand, the pattern that is in use here in this example is an async pattern of code. And I gather from looking at this stuff and the page I was looking at before this, it is possible to do something similar to how we might have done it in the Python code, and that might be an easy way out for doing things. But I really like the idea of learning a new thing, and learning a new thing means doing a new thing, even if that means I don't know how the hell that new thing is going to work. So we're going to focus today on maybe cleaning this code up a little bit if possible, but primarily turning it from an echo server that reads text and looks for the token EOF before it writes stuff back to the other side to at least an echo server that our client can send its binary messages to and get a result back, and we'll go from there. So again, I've been trying to think of how exactly to structure this, and right now, my best guess is I don't know. So until we get to a point where it needs to do something more than it's doing right now, I'm going to let that part slide. And I will let how what we need it to do at the time that that part becomes important guide in how it's going to be working. So I'm going to start the official 1 hour timer on my Fitbit and actually start at this time and not be confused and think that I went for 9 hours. And how exactly does this work? Well, that is a damn good question. Now, I say that because I'm not 100% sure of the internals of how this is working. First of all, easy stuff. Get the host entry for the current machine and use the first address. Now, that's probably not what we'd want to do for the same reasons we wouldn't want to do the same thing in Python. You want to look up probably one with a specific address family, like an IP4 address family or something. We create an IP endpoint that is that IP address on the port we're going to listen on, and we create a socket of the appropriate address family for that IP address, which again, we probably would want to make sure that's an IPv4, but for right now, that doesn't matter because that's not available to me. We want a stream socket as opposed to a datagram socket, and the protocol is going to be TCP. And here is the entire main of the whole operation. Well, realistically, this part right here. First, we're going to bind the endpoint and start listening with a backlog of 100 connections and say we're going to listen for connections. Now, what do we do through the loop? We have a, what would we call that? A manual reset event, which is something that threads can use to signal back and forth to each other. So it's a thread safe construct. We reset the flag on it. And here is the magic of how this all works. You call begin something, and you give it a callback to call when the something happens, and you give it a state object so that when the callback happens, it knows what the hell's going on. And then it's going to sit here and wait for a signal to be sent to this wait manual reset event. And so how this works is when you call begin accept, that spins off. Now, this is the part where I don't know what it's doing. It could be that internally it's got a list of sockets that it wants to do I/O on, and it's adding that to the list of readable sockets to select for so that when that gets selected, it knows it can invoke. Maybe there's another thread doing that. We don't know what's happening behind the scenes, but what we do know is that when the async callback or when the accept is happening or is about to happen or it has happened, depending on how you want to look at it, async or the accept callback, which is that async callback right there, is invoked. And the first thing we do is, now that we're here, we can go ahead and tell the main thread that to set the reset event to a flag so that this will unwedge and it'll come back, reset the event, start a new one. Now, my guess is that because this This call is a non-blocking call because it's beginning an asynchronous operation. It just immediately lands on this and essentially hangs here waiting for something else to trigger the event. So this is, I would gather, in this simple example, a way to make sure that this while true loop doesn't burn 100% of a CPU just sitting doing nothing, or trying to begin multiple asynchronous accept operations. And what do we do in here after we do that? Now, we get here an async result. The first thing we can get is the state, which is the parameter that was passed here, which gives us the listener, so that this event tells us the socket that the accept is happening on. And then we can say end accept. Now, I remember when I said all the asynchronous operations, and if you already know all of this stuff, then I apologize for how dumb this probably sounds. But for those of us like me, I'm just trying to explain to myself out loud how this works to get a good grip on it in my head. The begin something starts the async operation, and I imagine the end something is allowing an internal state on whatever this one was doing to know that this is done now. Now we know we got an incoming connection. We create a brand new state object, add that handler there, that socket to it, and then we can call begin receive. Now again, begin receive is the same as begin accept. It spins something off in an async thread, a separate thread. Maybe it forks a thread. I have no idea, but it knows to put data we want to receive data into this buffer starting at position 0, the start of the buffer, and we want to read uh, the size of the buffer. We want to try to read as much as possible into the buffer. This is a flag that we're just passing 0. I don't know what flags you might want to pass there. And then we have a read callback. And then this goes away. And then again, the read callback once again uses the state that was passed, which is that parameter there, which is now a state object. So it's not just a socket like it was up here. It's actually an entire object, which we can see right here, that has a socket and a buffer size and a string builder that is used to keep track of things. But if we come back down here, and I sort of bobbled that, I guess it was 100 and a bit. What do? We start off with an empty string. We get the state object. We get the socket out of there. And then we call end receive. And end receive is going to tell us how many bytes were actually put into that buffer. And it could be none. Perhaps. I would imagine that there is maybe a timeout operation, maybe a signal handler, depending on the platform. We don't know. All we know is it tells us how many bytes we read, and maybe we didn't read any. But if we did read some, we say what we read. We directly encode those bytes as UTF-8 and append them to the string builder, which is not something that is actually valid, because I am pretty sure that this is assuming that bytes read is a complete string. So if there were any UTF-8 characters that are multi-byte and the read split in the middle of one of them, this undoubtedly throws an exception or otherwise does something awful. But we can then examine the string builder that we have so far, and if we see that text, we know that we want to send the data to the remote end, but otherwise we want to just send off another receive at the start of the buffer so we can continue on and go again, and again we would eventually get another read callback. And when you call send, it encodes the data as bytes and begins a send operation. Same thing we've been seeing before. From the byte data that was encoded at position 0, try to write the entire length of bytes and get the async callback. Now, here's the part where I don't know. This is code that just came from a sample project, but it seems to me that since this indicates, if end send tells us how many bytes were sent, It seems like we should be tracking that so we know how many bytes are actually left. But this just assumes that it sent everything in one byte and then it shuts down the socket for reading and writing, closes it, and says it's closing the connection. And then the main has all of this other test code in it. So the first thing I suppose we might want to do is throw all of this code. Well, let's not say away. Let's just comment it out like so and uncomment that. And this we can leave here because we might need it in our debugging code. It's something you can use to turn a byte array into what looks like a byte array if you use the Python module or the Python byte array or tuple or whatever. Basically, so we can see the bytes in a better way than just saying byte square bracket in a length or something, which is what the default is. Um, so I'm going to compile that. Oh my, 297. Did I? Oh, did I just accidentally delete something out of there when I didn't mean to? Go away. Oh yeah, I did. Okay, that was a my bad type situation. Tonight's live stream is brought to you by a container of water and another midnight mocha coffee because these late nights are kind of killing me. I wake up ridiculously early on a weekend and I ended up staying up quite late last night as well. Apropos of nothing, if you are a follower of mine and you or use my override audit package, I'm gearing up to do a new release in the new year for version 2. There'll probably be a couple of small point revisions in the version 1. And Override Audit 2 is going to be basically the same as Override Audit 1, but it has had a BSR, which I like to use as a term, which stands for a big, scary refactor, to rejigger how all of the commands work to make it easier to extend it in the future. So what else might we want to do here? Now, let's just very quickly say swap test code sequences here. This this disables the code for testing message encode and decode operations and re-enables the network test code. And we're going to do that just after I stage the file as a single commit just so that the history is clean. Now, we might say instead of this, we might say that this is a build client. Okay, now that of course should have no effect on anything. And maybe I change this because I think it should be named socket and not state socket. That's crunky. And the receive buffer for this client. We track both an array as well as the size of that array. Okay. And this might be, whoops, read buffer size. And actually, I suppose I should probably do that this way. And buffer, we're going to skip that one. We're going to skip that one. We're going to keep that one. Skip, keep, keep, skip, skip, and skip. Oh, crunk, I think I went one too far. Well, we'll just say read buffer like so. And we're going to have to sort of vet these changes as we go through. I'm imagining that is going to still compile. I skipped over one that I did not mean to. So let's fix that real quick. Line 166. How's that? Is that making it happy? Okay, and let's just go through all of the changes. So we renamed that. That's probably cool. We renamed that. We renamed that. That's making a build client in accept. I don't like that. I might actually say that, and make that client. And again, this code is, except for some reformatting, pretty much identical to code that's on in the .NET documentation, and it doesn't use the sorts of variable naming conventions that I would use, which makes it trickier for me to understand the code quickly when I'm looking at it and I'm spending time trying to figure out what's that again. Oh yeah, that's that thing. This is one of the things I do. I like I am a person that learns by doing more than by watching. I enjoy watching, which is why I also enjoy creating videos for other people's to watch. Because I want to see someone doing something to get an idea of it, but it doesn't fully cement itself in my head until I do it myself. So if I'm following a tutorial, one of the things I'll do is go through and refactor and rename and things like that, and continue to make sure things are still working. It's a sort of a way to make the code your own. Okay, we're beginning receive on the into the client read buffer for the size of build client read buffer size with that async callback. That's looking like it's probably good. And again, here's a place where state and state and state and state and state and state and state should be client, because the build client is the state that was passed to that. Now those values are the same. And I don't like handler as, I mean, I guess it's an async handler, but we're assigning a socket to it. So I'm going to call it that. I didn't reflow any of these comments, did I? That might have been something that was smart to do. So we changed that. We made that slightly different. We're sending to the socket that content, which makes it reads smarter to me than send to the handler content. Again, that's just me. That's all personal preference. Here's one that actually wasn't supposed to have been modified, so we can go ahead and revert that one, but we'll reflow the comment anyway. We can reflow that as long as we're in the business of modifying the code. That looks like not what we want. Okay, now, yeah, that one was fixed. So there and there, and we're going to call socket there. Now, I would imagine that this actually should, if it passed the client in the send, then if it did a short send, that would be something that worked. So that is probably something that we can fix here. And maybe we want to do the thing where we send a message from the other side one byte at a time, and we make this one send one byte at a time to make sure that that still works for both of them. Send callback, again, that is a socket. And comments are looking okay. That's the main entry point. Now again, we still build this. And I'm just going to pedantically, if anything looks like a comment, we'll just reflow it. Because if we're in the area making what is not necessarily necessary changes, then let's go ahead and go full hog on that and get all of the code sort of up to snuff, if you will. I think there's one other thing that I might want to change here, but we're going to do that in a slightly different way. Now that code I'm totally going to leave alone, and I can build this. Now for the testing purposes of this, I can say remote build server and .NET run, and it'll run in here, so it's listening for any connections there, and I am going to, well, actually, I'll do this. I'll use this one, like so. Actually, but where's the settings in this bad boy? Instead of that font, what if I used that one whose name I can't quite remember at the moment, and I might have to actually go look and see. Oh, I have Fira code installed. Huh. Oh yeah, that's right. I was trying it out and it sort of drove me mildly crazy. Do. Hey, there's an ominously named Terminus font. Ah, there it is. That one. We want regular or bold. We want regular. Can I add partial sizes in here? Apparently I can. Okay. Here. That's using the same font as that. I'm working on using this particular font because it has some ligature support for some things. Obviously not this one, but I like all the stuff to have the same type of action. So if I telnet Dart on port 50,000, we can see that saying new incoming connection. At the same time, this says something here. Now something I actually wanted to test. Oh, escape character is. That's not going to do something, huh? That's more than a little weird, but I don't think I actually wanted to do that now. Okay, let's quit. Okay. Now there's probably a problem with this. The server doesn't seem to know that its connection has been closed. So that might be something of interest to look into, unless this is just not as smart as it could be. I'm going to kill it and start it again. Incidentally, I said at the beginning of day one, I added a key binding so that the build output panel, Control C, kills something. I later went on to confuse the hell out of myself when I was trying to copy data out of the terminal out of there to paste somewhere else, and it didn't work, and I had to use the menu, and it took me a while to realize that it's because I boosted the key. Okay. Mode character. So I'm not sure why exactly it read 6 bytes there. I think because this is telnet, it's actually sending stuff to the other side. But we can see that it's the telnet on my end is now sending a byte every time I type something instead of at the end of the line. So and EOF and one of these, and it said some random bytes and am a byte of text. This is a weird line of text. EOF connection closed by remote host. Okay, so still seems to work, except for the weirdness of how it doesn't notice when its connection goes away. So let's just say do a bit of code cleanup in order to understand the code a bit better. This changes the names of some values and reflows some comments. Should still structurally be the same as before, except that this is not a word that is spelled correctly, and we will stage that file and commit it. And I am going to very temporarily check out this commit like so, and do .NET clean, and, .NET clean, excuse me. It deleted some files, .NET build. Incidentally, this is the Terminus plugin if you're not familiar with it. It's still a work in progress. I have some minor problems with it, but by and large, it works great. And it works under all operating systems the same as far as I know. So it's pretty good in that regard. Now I can say .NET run. Now we're running the version of the code before I screwed around with naming variables. So what we might do is this. And my connection is closed and it still doesn't know about it. So that's not necessarily I wish I knew what those 6 bytes were comprised of. There we go. So that's still doing what one might expect. So let's go ahead and stop it. And, well, I guess I probably should have typed it here, but I can actually, I think if I don't already have the build system set to that, and I do, I can clean it from there. And we can actually see those things a bit better because the color codes are stripped out. And I'm going to go ahead and check out master to put the code back there and build it again. Now, I'm guessing it would be nice to know if there was an error reading from the socket before some sort of ridiculous timeout. I'm kind of surprised that that doesn't seem to at least generate an exception. So maybe we might say begin receive. We might actually, oh, I'm not a hacker. Yeah, do that. I mean, it has to be documented, right? Socket begin receive method. That seems like the one. And actually, we want .NET Core 2.1. Yeah, apparently there's a cooler version. Begins to asynchronously receive data from a connected socket. So which one are we passing? We are passing probably this one. Receive data from a connected socket. We're passing a byte, an offset in. Oh wait, what are we passing? We're passing a buffer, an offset, how many bytes to read, flags, callback. A buffer, how many bytes to read, an offset, flags. Oh, what's this socket error? Oh, maybe we're calling this one array of bytes for the thing, position, number of bytes to receive, a bitwise combination of socket flags, an async callback delegate that references the method to invoke when the operation is complete. User defined object contains information, returns I async results. Yeah, okay. So is there a flag that says we want to know about errors? Use no flags for this call. I probably should maybe be doing that. I don't want to send out of band data. Peek at incoming message. The control data did not fit. So not that, but if we went back one, we might find this one. Byte buffer, offset size, flags, socket error. Now, does that just tell us about an error right away? That is not necessarily cool. Maybe. Argument. The asynchronous begin receive operation must be completed by calling the end receive method. Typically, the method is invoked by the callback delegate. This method does not block until the operation is complete. To block until the operation is complete, use receive overloads to cancel the pending begin receive call close. For details information about the programming module, call, yeah. Receive a socket exception, use error code prior to obtaining. All IO initiated by given thread is canceled when that thread exits. Okay, so that's perhaps the execution context. I mean, I could put something in there to see, but I don't know what necessarily that would actually do. System net sockets socket error. Is there a... I mean, if this isn't out for an asynchronous call, I'm imagining that's not going to tell us hardly anything, right? Well, I mean, it's worth a call, I suppose. Let's just see what it does. Perhaps this stream will all be about not about actually updating the reads, but actually getting the network into a state where it can do something that we expect. Of course, we all know that the best way to learn something is to try. Tutorials are good for what they are, but no tutorial can tell you all of the information that you need to know about something. So let's go ahead and just copy that temporarily. And ay, Chihuahua. Let's give it a little bit of that action. Okay. So the read buffer, the offset, the read size, socket flags. Could I actually say socket flags dot none here and have it work? Or would I have to say sockets dot socket flags dot flags or something? Because that would be irritating. Okay, that might actually be a way to go, just because it makes it imminently clearer what the hell that 0 is supposed to be. And then we could do a little something like that. But after the flags, there's the out for socket error, error. And after that, we might say like thus. Is that how we do that? It's been a while since I've done it. Okay. And socket error, whoops, was that, and throw in error. And build, run the thing. Okay, it's listening for connections. Socket error was IO pending. All right, well, I mean, that makes sense. There wasn't any IO directly there, so okay. So maybe if you tried to do this when a socket was blocking, it might say something, or if it wasn't available for a reading or something. A line of text. We don't see anything there, and this is pretty much what I would have expected. And thus, so that does not actually do, for our purposes, anything that we really care about. But I do like how that looks, so I might actually, if the last commit was do a bit of code cleanup, we might actually go through here for, let's see, that's the begin receive there, and we got to remove that line. And read callback calls begin receive again. So this one would also be that, and that, and this one's a little longer, but, and that, and this would go like so, and okay, yeah, as I was doing that, I was thinking, I don't think I remembered to remove one of those things out of there after I did that, because I remember it all lined up nicely. Okay, so again, we'll just kill and run this bad boy, and Jello pudding pop. So that's still working. We're just gonna go in here and give that a stage and that an amend. Let's just make that code a little bit reader. Now maybe we might say C# async socket receive detect connection closed. Instantly detect client disconnection from server socket. Okay, how can I detect that a client is disconnected from my server? I have the following code in my accept callback. I don't think that has anything to do with the accept callback, but a neat way to discover that the client is disconnected. Since there are no events available to signal when a socket is disconnected, you have to poll it at a frequency that is acceptable to you. Using this extension method, you can have a reliable method to detect if a socket is disconnected. Okay, so that's what one might consider unfortunate. This method doesn't work unless the other end of the connection closes shuts down the socket. An unplugged network cable won't be noticed before the timeout period. Well, there's really no way to know in that case. An unplugged network cable is indistinguishable from a client that just never sends anything. That's why you should always call shutdown on a socket. If socket available, return 0. When you receive a packet just before poll gets called, poll will return true and the method will return false, although the socket is actually still healthy. Okay. A packet could be almost ready to be read, but not yet read, thus available being 0, but a millisecond later there's data to be read. A better option is to try to receive one byte and the socket flags peak, or implement some form of heartbeat and keep the connection status at a higher level, or rely on the error handling on your send receive methods and callbacks if using async versions. Yeah, you say that as if the async callback ever gets called. I would practically guarantee that the telnet that I'm using to talk to this thing is shutting down the thing. Just use poll for write with 0 microseconds. Okay. There's no physical connection. Oh, okay. Well, that's somebody maybe saying something different. Keep alive, not something. I don't know about that. I don't know about that. Oh, well. The key is you need to separate the thread, analyze the socket state with polling. See, that makes it seem like async socket programming isn't the way to go. If you use asynchronous methods for reading data from a network socket, like begin receive, end receive, whenever a connection is terminated, one of these situations appear. Either a message is sent with no data, even though begin receive is triggered, its value will be 0, or socket connected value will become false in this call. Maybe this is actually doing something and we're just stupidly not printing anything. That seems more likely because it seems ridiculous to imagine that someone would create something like, oh, I guess that actually was a read callback, wasn't it? We only get in there if we read bytes, so we don't get to see it say read 0 bytes, do we? That's a rookie mistake. Read callback. And I don't know that I necessarily should have required Stack Overflow to tell me that, but nevertheless, we built it. It's running. I actually don't know if .NET Run tries to build it first. I assume it doesn't. Hey, look at that. All right, so that's some kind of dumb on my part. Okay. You can see it with, okay. Socket.connected value becomes false. Okay. Well, if socket.connected, I as a programmer don't like to do this in languages that support it. I don't like to have that not at the front. Even if you're the sort of person that wants to do that, that one character is less readable to me than explicitly comparing things to Booleans. And I know I drive people absolutely nuts doing that sort of thing. I also don't like the notion of putting saying false equals socket connected to catch if you use one equal sign instead of two, because I'd rather the compiler tell me that I'm doing something dumb than have my code look yucky. So we might in fact here say client closed connection and just return in this case. Instead of doing that. Is there else on this? We might actually put that there so we can read some bytes and say how many we got. Maybe it's 0, but we only want to do something if it's more than 0. Okay, and if that was the case, too much Python. Try to learn when your tool does not provide appropriate colors for you. Oh, I did not need to do it that way. Oh, well. So I might say enter is 2 bytes. Yeah, character return line feed. Makes sense. Align, 8 bytes. Read, 0 bytes. And the connection is closed. I assume I'm not connected anymore. So maybe that we want the other of those two. Whenever a connection is terminated, one of these situations appear. Either a message is sent with no data. You can see it with socket available. Socket.available. Let's say socket properties available. Get the amount of data that has been received from the network and is available to be read. Well, maybe, I don't know which one of those is the better way to go. Or, oh, wrong one. We could also maybe say if bytes read was equal to 0 here, do the same thing. Maybe that's the logical progression to that. And we assume that if the read callback gets called without any actual data, the only reason for that is an error. Because there should be no reason why you said, hey, socket, go read me some data. Tell me when you have some. And the socket just wants to say, hi, Bob. I just wanted you to know I like your tie. I don't have any data yet. I'm going to keep looking. So let's quit that. We'll actually do it maybe that way. Hey, look, ampersands joined together in this font. Okay, now I imagine if I did the right thing. Okay, well, that's perhaps not what we expected. Now we can't talk to it anymore. Okay, so no, that's not what we want to do. Is there an error code available here? Methods. Begin, bind, cancel, close, connect, disconnect, end, hash. Any of these seem like they might do something? Let's look at that. Whenever a connection is terminated, one of these situations appear. Either a message is sent with no data, even though begin receive is triggered, its value will be 0, or socket connected. Oh, maybe I should look at this. Well, I mean, he did it the way that I don't like, but otherwise that is more or less exactly what I put there, right? Just a second ago. And that seemed to think that the socket was disconnected even though I just hit enter. And well, 2 people voted it up. Don't care about keep alive because it's not about keeping. If you called socket begin receive on the server program and then the client closed the connection gracefully, your receive callback will be called and end receive will return 0 bytes. These 0 bytes mean the client may have disconnected. You can then use the technique shown in the MSDN example to determine for sure. All right. I mean, I'm open. True if the socket was connected to a remote source as of the most recent operation, otherwise false. Well, that's what I have right there, isn't it? Connects to a remote, protects the connected property, and checks the current state of the connection. Okay. This is how you can determine whether a socket is still connected. Try to send no bytes. There's got to be a better way to do that because it seems like a ridiculous code smell to say that the only way an API could tell you if a socket was closed is to try to do something to it and see what happens. I mean, I guess Python kind of works with that whole easier to ask for forgiveness than beg for permission. Or EAFP, easier to ask for forgiveness than permission. It's easier to do something and see if it fails and catch an exception than it is to test to see if you should actually do it. So I don't know that I necessarily trust either of those two things, but it might be interesting to wonder why that was the case. We're going to Control C that. We're going to build. We're going to give that the focus and build. So it's definitely going. That's definitely done. And we're just going to go ahead and just do .NET run here. So it's zooping along. And let's test it one more time. Now, again, I just push enter. And that says read 2 bytes. So I want to actually test this. We might say socket dot connected and socket dot available and remove those because we were sort of doing nothing with it before anyway. I probably should not have done that, but nevertheless. There are 0 bytes available, but end receive returned 2 bytes. Gotta say, not sure. Maybe try to quit and see. Now it read 7 bytes. Oh, I used the wrong thing. Read 0 bytes when it closed. So maybe that is actually the way to do that. I believe if you're using a blocking socket, that's how that actually works. I don't need to create a terminal. I can just do that. If we were to look at number of bytes received -1 if an error occurred. In the event of an error, Erno was set to indicate the error. When a stream socket peer has performed an orderly shutdown, the return value will be 0, the traditional end of file return. Okay, so I guess it's just using a blocking socket in a magic way. So let us just say, well, we might actually do it here. If bytes read, and we'll have to do that, is equal to 0, then client closed connection and return don't do anything. Otherwise, I'm imagining end receive can't return a negative value, but I don't actually know, so let's check. Can I type? Returns the number of bytes received. Okay. That's weird. If red is greater than 0, so I guess that's sort of inherently noticing that it's closed. But if it says it returns the number of bytes read, you can't return -1, and I imagine it would say some sort of error code. Within the callback call, the async state method of the to obtain the state object, extract the socket. After obtaining the socket, you can call end receive to successfully complete and return the number of bytes read. End receive will block until data is available. If you're using a connectionless protocol, end receive will receive the first enqueued datagram. If you're using a connection, receive as much data as is available up to the number of bytes you specified in size. If the remote host shuts down the socket, all available data has been received, and receive will simply complete immediately and return 0. To receive data, call the async state method to extract the buffer contained in the resulting state object. To cancel the pending receive, call close. If you receive a socket exception, use error code to obtain the thing. So I'm guessing, yeah, 0 just means end of. So that was actually kind of documented. So if that's the case, then we don't need this, or which was the matching one? That one, I guess. No. Let's do that more smarterer. The match of that one is that one. So kill that, move all of that over, kill that, because it's either 0 or it's not. And again, well, maybe, yeah, we'll leave it there. So we do that, and quit and run. And I can telnet to the thing and say, like so, it gets the 6 bytes, because apparently you can't do that without negotiating in telnet. 4, 5, 6, 7, 8, 9, 0, A, B, C, D, E, F. Enter. Now, if I quit telnet, I get client closed connection over there, and that connection presumably just goes away. But that still works, and then it closes the connection to me. So that's probably what we want. Now, could the same be said for end send? Ends a pending asynchronous send. If successful, the number of bytes sent to the socket, otherwise an invalid socket error. It seems weird that it would return an int. You need to create within the callback. If you're using a connection list, okay, there's no guarantee that the data you send will appear on the network immediately. To increase network efficiency, the underlying system may delay transmission until a significant amount of outgoing data is collected. A successful completion of begin send means that the underlying system has had room to buffer your data for a network send. Okay. Successful completion does not indicate the data was successfully delivered. If no buffer space is available within the transport system to hold, send will block unless the socket has been placed in non-blocking mode. So yeah, it sounds like this is actually a blocking call, but the asynchronous makes it not necessarily block. So hopefully that doesn't cause the same sort of race condition-y type errors as I have seen before. So if we went back up to, and I'm not even entirely sure how one might coax this out of the system. That links to, yeah, so maybe we're not going to worry about that at the moment because I'm not entirely sure what the value of that would even be in that case. And it's kind of hard to contrive a send failure because it requires me to quit the other end pretty quickly. And what actually changed here? Let's see what we have done. We added the ability to detect if a connection was closed. All of that code is otherwise the same, but just moved over. And that's the only thing that changed. So let's stage that and say, detect read errors properly. So maybe we want to actually try and make the send do what we want. How much time do we have? It's pretty much at an hour, but I'm going to go a little bit longer because this is a stream that doesn't have a whole lot of stuff in it. Sometimes this is just the way it goes. In order to do something, you got to feel your way around. There could be documentation to read. You might not fully understand the documentation, so try things out and maybe you can come to a conclusion about how things are supposed to work, or maybe you go to Stack Overflow and ask your own question. But you get faster results if you look for your own answer first. At least I've always thought so. Okay. This uses the realization that end receive returns a value of 0 to indicate that the other end has gracefully closed the connection. In that case, we consider this connection closed and do no further action on it. Now, realistically, that's probably not necessarily what we want, because if there's some client object, we may need to close down some state for it. But until we have that stuff, we don't really know how we might go about doing something like that, right? So that is neither here nor there. Now, if we look again at and send the number of bytes sent to the socket, otherwise an invalid socket error. So if we were actually to try to send data, and we were actually using begin send for a buffer and offset a size, flag none, and async callback in a state, an array of type byte that contains the data to send, the 0-based offset at which to begin sending data, the number of bytes to send, bitwise combination of the flags. So I think, okay, oh, what do we got here? Exceptions. Buffer is null. Argument out of range. Offsets less than 0 or less than the length of the buffer, or so doing dumb type stuff. Starts in async, begins in async. So I'm going to say that much in the same way that we have a read buffer size and a read buffer, I don't like this. realistically. Is that all of them? Undo that one. String buff, let's say. When we actually decide that we want to send data to the other side, now that actually builds, right? We're going to call send with the socket and the content, which is a string. So the string buffer is just us accumulating data into a buffer. We need to have it as a string so that we can look for that particular sentinel. So we'll leave that well enough alone. But what we want is for this to be stored in the buffer, the client itself. So maybe up here, we might have a public byte send buffer, which doesn't have anything yet because it's going to be assigned to that thing, and public int bytes sent. Well, maybe default that to, no, we won't. Okay. The send buffer, oh, there was one of those that shouldn't have been changed, but too late now. Well, the receive buffer for this client, we track both the array as well as size of the array. The send buffer for this client. This gets assigned when we receive a complete message and tracks the bytes to send. The bytes sent value is used to indicate how many bytes are actually transmitted so far. Okay, so I imagine that should still be completely kosher, and we're going to go ahead and not do it that way. I do it this way. Copy, jump to send. We want this. Now, I think that means that we don't want to call socket here. We want this to be a build client, and instead of calling send socket, we would call send client, like so. And now here, we say, instead of socket.begin, we can say client.socket.begin, and we have to move that over. And instead of byte data is encoding, we say client.send buffer is equal to that, and client.bytes sent is equal to 0, so we can track. We are still converting it for, okay, now we're doing that. We are not passing the socket as the begin send. We are again passing the client to get a full state. And that means that we need to do this instead of what we were doing in the send callback. Notice this one has a try, whereas the other one didn't, which is also somewhat suspect, but build client is that, and the socket is client socket, like so. Sent 0 bytes to client. Now we say if byte sent plus client, oh, no. We say client.bytes sent. I'm going to do it this way to begin with, plus equals bytes sent. And then we can say if client.bytes sent is equal to client.sendBuffer.length, then and only then do we shut down the socket and close the connection. Otherwise, we want to do this again. And I'm going to do it this way, just so we can see that. Client begin send, not from, oh, that's not correct. We want to send from here. Let's fix this one first and then fix that one. So we want to send from client send buffer at offset 0. Yes, because we're just starting the send now for the entire client send buffer length of bytes with no flags with the async callback like so. So yeah, just try to write the whole thing. That seems like a good thing to do. And if that didn't work, then we need to send again. That's too many. And now we're sending from client send buffer again, but now the offset is client.bytes sent. And we want to send the length of the buffer minus client.bytes sent. So, oops, excuse me, if there were 10 bytes and we sent 1, then we want to start at position 1 because the one at position 0 was sent, and we want to now transmit 9 bytes instead of 10 because 1 byte was sent with none to the client, like so. And I imagine this should, if it compiles, still do what it was doing previously. I am a line of text. And there we say it doing that. It sent the bytes. Now, that still works. That is testing that. So that is testing that the whole send goes, right? So here, this is going to be a situation wherein I say update the send operation to be incremental. This makes the send of the echoed data back to the client be potentially incremental in nature, so that if the entire result can't be transmitted in a single operation, we spread it around. Okay, and we're gonna see we added a buffer and the number of bytes that were sent. That looks good. We changed that to be less ugly, and now the socket, instead of passing a socket, we pass a client, so we can stage that. Now, instead of taking a socket, we take a client, which means we need to use client socket in a couple of places, and instead of having just a value that we hope goes, we store the encoded data into the client. Say we sent no bytes, try to send from the client buffer starting at position 0 the entire length with no flags, send the client as a state, and it receives the build client and pulls the socket out. And once it receives some data, it adds the bytes sent to the number of bytes sent to the client. If that equals how big the bytes were supposed to be, then it shuts down the socket, closes it, and says it's closing a connection. Otherwise, it commences another send operation that starts in this client send buffer, starting at starting at the position where the bytes sent is. So 0 if no bytes were sent, 1 if 1 byte was sent, so on, sending the entire length minus the number of bytes already sent with no flags. That all seems to be good. So let's commit that. Now, for the purposes of testing, I'm going to first kill that. And boy, I made that quite unhappy. I don't know what I did. Oh, I think I accidentally pasted some data in there. Okay. Here's what we're going to do here. We're going to say that the initial send, instead of sending client send buffer length, sends 1 byte. And down here in the send callback, instead of sending the entirety of the buffer less the number of bytes sent, we're going to send 1. And if we were to do that, then when we have the correct code here, and I connect, and I say HELLO, which is 1, 2, 3, 4, 5 bytes, we should see 5 send operations, and then it'll be done. Oh, sorry. I also have to do that, so now I wrecked it. But nevertheless, so what do we got? HELLO, new line, carriage return. How did it get 7 bytes? I screwed myself up with that by doing that, so let's try that again and start. HELLO. Oh yeah, EOF is characters. It's not a control character so much as it looks like one. So what is the data that we got sent? HELLO less than EOF greater than carriage return line feed closing the connection, and we got that. So we have successfully done that little bit of operation. Now we can try to test what happens here. In what may possibly be a very terrible idea, if I copy or if I select all of that text and come over here, oh, shoot. If I select all that text and come over here and middle click, unfortunately, the word EOF appears in that code, so that was perhaps not the cleverest thing to do. And I may or may not have broken terminus as a result. So I'm going to quit and restart. Now there are some small issues with terminus. I'm not going to lie, it's not perfect. It's not terrible either. Sometimes things go wrong. So .NET. Oh, I got to go into remote build server and .NET run. We get that. Maybe the text doesn't appear in this one, so I'll select all of that text first. Come to here and do that. Now this might actually still make terminus mightily unhappy, so we'll see what happens. But I'm going to paste that in. Notice all of those bytes that we got there. It's going to send the whole file back. And even though the buffer is 1,024 bytes, the first time it only got 502, then it filled up the buffer for the rest of them. That's sort of the magic of how these things work. EOF. And while that's going, I am going to try to quit this thing. And what do we get at socket begin send? So begin send through a broken pipe exception. And begin send happens here. So let's just take a quick look at exceptions begin send should use. Socket exception, let's say. Use socket exception error code to obtain the specific error code. Okay, so what if I said catch socket exception SE and I said to write socket error that SE and closing connection, let's say. And I don't know if it's actually safe to call close on the socket here, so I'm not going to. I'm just going to say that that's what happened and build. And, oh, let's try that maybe. There we go. Let's build it one more time just to make sure. Okay, so we're going to .NET run over there. And again, we are going to preload all of our data like so. Look how it worked this time. 502, 875, 3 at 1024, and then a 41. Then we say EOF. And now I screwed that one up. I was trying to type it too fast. So let's try it again. EOF. Socket error. Broken pipe at doot 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 closing connection. Is that what it said before? I better double check. Socket error detected. I should say closing connection. Is that what it said? Yes. So maybe we might want a little something like se.message. Is that how that works? Instead of the stack trace. And I'm pretty sure, again, it's going to be mad. Okay. So we run it and go to the terminal and jump in. I need to grab the data again and preload it in. This is, the vagaries of networking, why you want to have the ability to do partial sendy type stuff. EOF and quit. And okay, that time we just made it sort of unhappy. Socket error, broken pipe, closing connection. All right, so we didn't necessarily do what we intended to do, but yeah, I know. We did actually make it smarter. So we actually want to commit, we want to stage those lines, and I'm going to amend the previous commit because that's part of the send operation. And we can discard that hunk and that hunk because that was just testing. And I will also create a tag for day 08. And I can push that code up. We actually get to see it this time because the nature of the changes that I have been making is requiring me to make commit changes. Now, this is a workflow that I use fairly often, which is to commit early, commit often when I'm testing on stuff like this. Now, if I had determined that all of this stuff didn't go anywhere, I could just reset master back to this commit because I still want that code cleanup and do not worry about anything that I worked on. But if it did work, then I want to check stuff in so that I can do things like those incremental changes, like changing those couple of values to 1. And then when I'm verified that those changes do what I expected, I can tell that those are the only changes that I made since the last time it worked, which is easier for me to track in my head than trying to remember all of the diffs. And that is going to do it for this part of the operation for Devember. Saturday, December 8th. I'm going to jump on out of the stream and jump on into creating a devlog to tell people what we were doing here. Now, we didn't actually set this up to read and write binary messages, but what we did do was give it the ability to do partial sends the same way that we do partial sends on the other end. We're not yet doing partial reads, but the code was already set up to be able to read bytes into a buffer and do something with them. So we are pretty good to go in that regard. Now, following on tomorrow, then what we're actually going to try to do is that part so that we can transmit binary messages instead of this whole telnet thing. That's going to make testing this harder later because we're not going to be able to type our own text messages in, but we can use our Python client to send messages back and forth. And that, if we have the basis of that, we have the potential to start moving into actual build system territory because we have the ability to have a task on one machine run something and another machine run something and interoperate between the two. So I have to think about how exactly we want to proceed there. I think we want to build up the protocol and design how we want it to work first, then start building toward that goal. And as we go, we might determine if the server is working for us, how to structure being able to send data back. When we definitely right now, we can send results back to a client in response to a message that it sent. So that's 90% of the way there. The thing to worry about is how do we send ad hoc messages to a client if we need to do so? And I'm guessing once we get there, that part will be fairly obvious. So my guess, for example, is when we spawn off the task that's actually doing the run of the operation, we're going to need to capture standard output and standard error. We're probably going to need an async handler somewhat similar to this. That state object could contain the socket or contain the client. So every time a result comes, it knows where to send it. So that's why I'm not worrying about that right now. Worry about problems as they arise. And of course, none of this is production ready because it still has various error handling that would be a best practices thing, but always make it good work, then make it pretty. So until tomorrow's live dev stream, this is ODAT Nerd giving you the invisible salute that you can't see because I don't stream a camera due to not having one that I can stream with, saying have a sublime day and we will see you tomorrow.